All right. We're supposed to represent these questions with fractions. So number 2 here, of the 95 executives at a private accounting firm, 36 are women. Then it goes on to say what fraction are women. Okay. 36 are women. So 36 out of 95 are women. All right, I hope that's intuitive. And we cannot reduce 36 over 95 because there are no common factors. Okay, so that would be our answer for number 2. If we move on to number 3, they can ask these questions in a slightly different way. Of 108 bicycles in a bike rack, 41 are mountain bikes. And then it says, what fraction are not mountain bikes? All right, whoops, that kind of didn't fit. Well, let's zoom out a little here. Let's try this direction. Okay, so what fraction are not mountain bikes? Well, if 41 out of 108 are, to find out how many are not, we're going to have to take our 108, subtract 41. That'll give us 67. So that means that 67 out of 108 are not mountain bikes. Okay? And let's see, 67. It's not divisible by 2, 3, or 5. Got a feeling that's a prime. So I'm not going to worry too much about it being reducible. Okay, so we'll go with that answer. And then let's see, they want us to graph some of these on a number line. We'll take a look at number 6 here, 10/3. There's different ways to approach this, but I think it's easier to, I think I'll zoom in some on this. There we go. One more, why not? All right, let's see, our 10/3. They want to graph this on a number line. For me, it's easier to think of if this is a mixed number. So to change an improper fraction to mixed, you do what it tells you to do. This is 10 divided by 3. I might even zoom in one more. I hope that focus is still good. Sorry for that little delay there. All right, so 10 divided by 3. 3 goes into 10 3 times, with 1 left over. So 10/3 can be written as 3, and this 1 is your new numerator, but you keep your denominator. Okay? So 10/3 is the same as 3 1/3. Okay? A lot of 3's on the paper here, but this denominator is the same denominator you have right there. Okay? And to graph 3 1/3, 3 1/3 sits someplace between what two numbers? 2 and 3. Or actually, I'm going to have to say 3 and 4. 3 and 4. Okay, so I'll go, here's my 2, here's my 3, here's my 4. And this tells you how many places you have to divide it up into. it's divided up into thirds. So between the 3 and the 4, that's 1/3, 2/3, 3/3. Okay. 3 and 3/3 is the same as 4. So that should make sense that I landed there. These are supposed to be spaced evenly. Sorry, I'm a little bit off on that. So 3 and 1/3 would be, from 3 you come over 1/3, so you would put a dot right there. 3 and 1/3. Okay? I think I'll leave it at that. You could think of 10/3. If this number line was extended from 0 and I counted up all the thirds, I would have 10 of them when I got there. I think it's easier to just say it's 3 and 1/3. Okay, let's see. Some of these others, simplify by dividing. This is just keeping up with the rules for multiplication and division are the same as far as positives and negatives. Okay, negative divided by a negative, it's going to give you a positive, and 23 by 23 is certainly a 1. So that's what's going on here. 33 divided by 0 is undefined. You might say 0 under is undefined. But 0 divided by 18 is 0. So maybe I'll just show real briefly. This is undefined. And this is equal to 0. That might seem strange. I'll try explaining why. Basically, I just memorized it for a long time. But if you want to try to understand why is that so, let's look at what division means. Okay? If I say 12 divided by 3 is 4, the meaning of division is if I check this and say 4 times 3, I'm supposed to get what I started with. And in fact, I get 12. So that worked. Let's do one more example. If I had, let's say, 35 divided by 5, I claim the answer is 7. And for this to be correct, I have to be able to say that 7 times 5 is equal to what I started with, and it is. And if you look at, I think I'm going to zoom out a tiny bit here. And you look at our last one here, I said that the answer to number 11 here is 0. 0 divided by 18, I claim is 0. Well, we have to be able to check it the same way we just check these. So 0 times 18, does that equal to 0? Yes. So that checked. But look what happens. I'll zoom out one more. Look what happens when we try number 10 here, 33 divided by 0. 33 divided by 0. It's supposed to be undefined. Alright? But let's say you're going to try to say that it's 0. So we'll, it's supposed to be undefined, okay? But we'll try 0 and see what happens. Well, if 0 is the answer, then I have to be able to multiply 0, this red 0 times this 0, and is that equal to 33? No. So that's why we say division by 0 is undefined. Okay? Let's take a look at, see some of the next ones we'll do here. 12, 15. I should do number 12, so let's get number 12 in here. And we'll have to zoom in a little bit. So they want this as an improper fraction. Well, we will oblige them. To change a mixed number to an improper fraction, you multiply 4 times 7, and then you add the numerator. So 4 times 7 would be 28 plus 3 is 31, and you keep your denominator, so 31/4. Okay. Incidentally, you can go from 31/4 back to 7 3/4 because 31 divided by 4 divided by 4, it goes in 7 times. When you subtract, you have 3 left over. 7 and 3, you keep your denominator, 4ths. Okay, so you can just switch back and forth. You're not changing the value of the number, you're just changing the way it looks. And that's pretty much the deal in math. You're not allowed to change the value. You can always change the way it looks. Alright, we'll take a look at number 15, 16, 17. Well, we just went over how to do these. Maybe I'll just tackle the big one here. 196 divided by 14. It goes in once. And 14 actually goes into 56. And you might, the more you work with this, the more you'll start seeing the little tricks. But I'm really paying attention to the ones place and the ones place. 4 times 4 is 16. And so 4 times 10 would be 40, plus 16 would be 56. Okay? So that's 4 times. 4 times 14 is 56. Nothing left over. So 196 over 14 is 14. Usually there is a little bit of a remainder, like on this one here. 8 divided by 3. 3 goes into 8 twice with 2 left over, and you keep your denominator. Okay? So that would be number 17. All right? Prime factorization. I think we'll put prime on the next video.